In this video, I'll be walking you through on introduction to integration. Introduction to integration. This is Further Solutions Academy. Further Solutions Academy. Please encourage us by sharing our videos to your friends and also subscribe to our channel. Help us to subscribe or like our videos. Now, this is Further Solutions Academy. Now, I want to be working on what? Introduction to integration. Integration is a very wide part of mathematics. It's very wide. It's very wide. But these are the foundation to all about what? Integration. Any student can understand special integral, changing of variable, and substitution method, integral by parts, by partial fraction, and also integral by parts. I think you should not have problem with this. I won't go deep here. I will just explain the outside part of it, because this two part is very deep. But this one, I will really explain it very well. I will explain it and I will try to gather some solution on it. Now, let's start from definition of integration. Definition of what? Integration. Now, if I'm talking about integration, with what I've said, is very wide. Integration is very wide. Now, when we are talking about definition of integration, number one, integration is from calculus, and calculus gives birth to two, which is called differential calculus and integral calculus. Now, both of them, they are reversal of each other. If one is going front, what will bring it back is what? If differentiation is going front, what will bring back differentiation is what? Integration. It's integration. From our slope or gradient. With the help of our slope and gradient, you can integrate back and have your what? Equation. Now, okay, and they are reversal of each other. Now, but there are two branches of integration. The first one is called definite, indefinite. Let me just start from indefinite integral. And the second one is indefinite integral. Now, indefinite integral, and the second one is what? Definite integral. Now, definite integral and what? Indefinite integral. Now, this one, it always include what? Constant, which is what? Constant k. I'm always attach what? After integrating, I will attach a constant. It can be k, it can be what? Mostly in mathematics, we use k and c to denote constant. Now, or you can use your own convenient letter. Now, for instance, if I want to integrate something like this, x raised to power n dx, it means if I should integrate this, it will be what? X raised to power n plus 1 all over n plus 1 equals to, plus what? Plus k. Attached to what? K constant will be what? Attached to it. Some textbook use k, some use c. You can use any letter as far as you can define it, which is what? That is all about what? Indefinite integral. Now, why definite integral? This definite integrals has two, also this one has two branches. The first one is always with what? When you are talking about what? A coordinate, it will involve a coordinate, which is what? X and y. It will involve a coordinate, which is x and y. While the second one, it always involve what? Upper limit and lower limit. Now, This one is very, very common, I think, under our real analysis. When we go to advanced mathematics, Riemann integral, and so on and so forth, we'll be working on a lot of work on this Riemann integral, and also application part of what integration. We will be also be using this last part of what definite integral. Now, that is all about definition of what integration. Let me give out some problems. Okay, don't forget that our integration sign is denoted by what? By this, which is anytime you have this sign of a function, but it must end with what? Respect of what? X. Now, if I have a function like this, I have x with respect of x, but if I now have another one, integral of what? X with respect of theta. Now, look at these two things. This particular one, I'm going with respect of x, while this particular one, I'm going with respect of theta. And note in your mind that anytime you are asked to integrate, you always want, at this point now, I will be having x raised to the power 1 plus 1, because power 1 is here, divided by 1 plus 1 plus k. But here, I'll be having my x raised to power theta raised to power 0, integral of what? The theta. Now, that is what I'm having here, which if I should integrate x theta raised to power 0 plus 1 divided by what? Is 0 plus 1 plus k. Now, can you see what's the difference? This time around, I'm working with respect of x, while here I'm working with respect of what? Of theta. Now, at this point, I'll be having x squared 2 plus k. While this one, I'll be s theta divided by 1, which is 1 is an identity. 1 is an identity. I have this. Now, can you see the difference between them? That is how this integration works. Now, if it's on the other part, which is definite integral, is either I have my coordinates or I have my limits. Once I have my limit, the k will not be there. I will now be working on what? Upper limit minus what? Lower limit. I think when we get there, I will try to explain that part also. Okay. So with the help of this, let me bring out some problems on integration. The first one is my slope. My slope or my gradient is equals to changing y all over changing x. Okay, let me give a equation which is equals to what? 3x squared. Okay, let me put 30 here. Okay, plus 3x. That is the first one. I want to find what? I want to find my equation. Find y. Now, this question is not complete. If I have my coordinates x and y, it means I will have my upper limit and what? Over lower limit. Now, if I want to solve this particular problem, solution. Now, my dy, dx is equals to what? 30x squared minus 3x, which I have y equals to 30x squared 3x, all bracket of what? The x. Now, this one, I'm having y raised to power 0 integral, and I'm integrating here. Now, what I'm having here, it means y raised to power 0, 1, all over 0 plus 1, which is equals to this particular one. This one is, I won't attach constant to it because it's an independent variable. Now, why this one, I'll be having 30x 2 plus 1 all over 2 plus 1 minus 3x 1 plus 1 all over 1 plus 1 plus k, which I will have now y all over 1 equals to what? This one will be what? 3, which is I have 30, which is I have 10. S raised to power 3 minus what? 3x squared plus k. That is my y. That is my y. Now, let me give another problem. Let me give out another problem. Another problem is if I have something related to this. I have integral of what? 1 minus x all over 1 minus s all over x raised to power 3, all with respect of what? Of x. Now, I want to integrate this question. Now, if I should integrate this question, I can have my what? Integral of what? 1 with help of my fraction. If I have a plus b all over c, it can be written as a all over c plus b all over c, which is very, very possible. What I will do here, I will have 1 all over s raised to power 3 minus s all over s raised to power 2, power 3, with respect of what? The x. Now, if I should go for property of integration, I can return this by what? Integral of 1, I can say that what? S raised to power minus 3 indices, which is inverse of it. This one will be what? S raised to power minus 2 with respect of x. Now, at this point, I want to add up and take away. Now, I will add s plus 1 divided by plus 1 minus s plus 1 divided by 2 plus 1 plus what? K, which I will have. This will be what? S raised to power minus 2 all over minus 2 minus, which is, I have s raised to power minus 1 all over what? Minus 1 plus k. At this junction, I'll be having minus 1 all over what? 2x squared plus, minus interact with themselves, plus, which I have 1 all over what? S plus k. That is my final answer. That is my final answer. Now, okay, let me move on to special case of integration. Special case of integration. Now, this special case, there are some like trigonometry, exponential, and also what's the name? Link function. They are all special. I won't do much of integration because this is just like introduction class. Now, okay, for instance, if I want to integrate my cos theta with respect of x, I want to integrate my cos theta with respect of x. Okay, cos theta with respect of x, sin theta, sin x with respect of x, and also if I have, let me neglect tan for now because tan is another special case. Now, integral of e of x dx, and also integral of 1 all over x dx. Now, this one will give me what? This one will give me sine x plus k. This one will give me minus cos x plus k. Why this one will give me ex plus k. Why this one will give me ln of what? Ln of what? X plus what? K. These are special case for this introduction part. There are more of them, but these are special that I'll be using for this introduction part. Now, okay, let me give out some problem that can really be of help. Okay, for instance, if I have a particular question, take note of this information, they are special case I've used. Now, okay, if I have, for instance, I want to integrate these two problems. I have integral of, okay, if I want to integrate this particular problem, I have integral of 1 all over s plus cos theta, cos x with respect of what? X, which is number 1. I want to integrate it, I want to evaluate it. Let me evaluate it. Okay, I have the first one and the second one, and let me look at another question that can be of help to us. Okay, if I have number 2, I have evaluate also integral of x squared plus 3x plus 3 all divided by x plus 1 all integral with respect of x. Now, I want to integrate these two problems. The first one, it will be very simple. I will just have my solution. I want to now the first one, integral of 1 over s plus what? Cos x with respect of what? X can be equals to what? Integral of 1 over s dx plus integral of what? Cos x dx. Now, if I should have this, it's a special case. Yeah, special case. I will have ln x plus this one. If I should integrate my cos, I will have sine x plus what? K, my final answer. No problem. That's all. Now, but this one, how do I solve this particular problem? What I will just do is that what? I will have integral of what? X squared plus 3x plus 3 all divided by x plus 1 all bracket of what? The x. Now, this is polynomial and quadratic. You can't go towards partial fraction. If it is partial fraction, it will be linear. I mean, this is quadratic, this is linear. If it is partial fraction, it will be what? Linear all over quadratic. But this one is another case. Now, can I factorize that upper case? I think I can factorize it. Now, my factor 3 and prime number 3 and it means I'll be working around with what? With 1 and 3. Okay, if I put 1 here, can it be equal to? Okay, I want to factor. I'm trying to factorize. It means my x plus 2, my x plus 1. I think, yes. Open this bracket, I will get this. X squared, 3 yes, 3, oh, sorry, I made mistaken. Now, x squared, yes, yes. Now, sorry, the question must be 2 here. Let me not complicate the issue. Now, okay, I factorized successfully. Now, divided by x plus 1, all integral with respect of x. This will cancel this. Very successful. Now, I have integral of 2 of x dx, which I have x squared all over 2 plus 2s plus k. That is my final answer. That is my final answer. Now, let's move on to integral by substitution. Changing of variable. Integral by changing of variable. Now, okay, integral by changing of variable. Now, this one is very, let me put change of variable here. Now, this is very simple. For instance, I want to integrate cos 2 theta with respect of theta. This is very simple. Now, I want to integrate this particular problem. What I will just do is, let me put solution in. Okay, evaluate. Let me just evaluate it. Now, let u equals to what? 2 theta. The u equals to what? 2 the what? The theta. Now, what I'm working is what? Now, it means my d theta can be equals to du all over 2. Now, I can now come back to what? My integral, which I have cos u. What is my theta? The theta is what? Du all over 2. I can answer 1 all over what? 2, because it's a constant. Sorry, I have to give you property of maybe our next video I will start from property of integration. Now I will be having this, which I will have cos u du. Now, anytime I'm working on integration, what I'm after is what? This with the respect must be what? Equal. Now I can say what? What is my integral? I can say the amount of which is what? Sine u plus k. Now, what is my u? Hence, my u is equals to 2 theta. Therefore, now 1 all over 2 sine what? 2 theta plus k. That's my final answer. That is my final answer. Now, that is, I'm changing the what? The variable. Let me try to solve in the algebraic form. Now, another way, if I have this particular problem, I have this type of problem, I want to integrate something like this. I have integral of 2x plus 3, or bracket of what? Or bracket of, let me put square, let me do too much. The x, and I'm asked to what? Integrate this particular problem. 2x, let that be 2 here. Okay, let that be 2 here. Now, I want to integrate this particular problem. Let me make it a bit. I have 2 all over 3. Now, if it is ordinary square, I will just expand and I will go. But let me make it a bit complicated. I mean, a bit complex. 2 all over 3. Now, if I should do this, I can have this as 2 integral of what? 2x plus theta, or bracket of what? 2 all over 3 with respect of theta. What I'm just doing is that let u equals to what? 2x plus 3. The u, it will be what? 2 dx. Now, my dx, therefore, my ds, it will be what? Du all over 2. I will now move on again. I have my 2. What is my, I have my u raised to power 1, 2 all over 3. 2 all over 3. What is my du all over 2? Now, which also implies 2 all over 2 integral of what? 2 all over 3 du. This will surely cancel themselves, which is equals to 1. Now, I cannot integrate. I will add 1. If I have 1, it will be what? U raised to power 5 all over 3 divided by 5 all over 3 plus what? Plus k, because it's an indefinite integral. Now, after this, I'll be having with my 3 u 5 raised to power over 3 divided by 5 plus k. Now, at this point, I can now say that what is my u? Hence, my u is equals to what? 2x plus 3. Now, I can answer that what? My u is equals to 2x plus 3. I can have 3 all over 5. What's the name? 2x plus 3, or bracket of what? 5 all over 3 plus k. That is my final answer. Now, okay, should I bring more example on this changing of variable? Okay, if I have another one of this case, okay, I have another one of this case. I want to evaluate this particular problem. I want to evaluate integral of cos 3x plus sine 4x, or bracket of what? The x. This is another case that you can see in any exam. Now, if you are asked to solve this particular problem, what I will just do is that what? Solution. Now, the first one, I can turn it to what? Integral of cos 3x dx plus integral of what? Sine 4x dx. Now, what I will just do is that let u equals to 3x. At this point also, let u equals to 4x. Now, if I should integrate this, I have du equals to what? 3 dx. My dx, therefore, my dx will be what? Du all over 3. And also the same thing, du equals to what? 4 dx. My ds equals to what? Du all over 4. Now, what I will just do at this junction is what? There are two things This is for the first one, this is for the second one. Now, I will now move on by having cos of what? Cos u, the what? U all over 3 plus sine u du all over 4. Now, I don't know, they are constant. They are constant. Don't worry, next video I'll work on property of what? Integration. All over what? Cos u du plus 1 all over 4 sine u du. Now, if I integrate my cos, I will have 1 all over 3 sine u plus also 1 all over 4 minus cos u plus k. Is very important. Now, because it's an indefinite integral. Now, which also implies, what is my u? U of my sine is this. I mean, u of the first one is this. I can say that what? 1 all over 3 sine. What is my u here? I have plus minus. It will be minus 1 all over 4 cos 4x plus k. That is my final answer. That is my final answer. Now, you can do more of that. There won't be any issue. Now, don't just do more of that. That is all about changing of variable. Now, let's move on to integral. I don't even know which one we do next. Okay. Now, let me move on to integral of okay, the one that integral of substitution. Let me move on to integral of substitution. Now, substitution. This one also is very interesting. It's very, very interesting. Now, how do I solve substitution? Now, I have, for instance, if I have integral of what? Of this nature, x squared minus 1, or bracket of 2x dx. I'm to what? Evaluate it. Let me evaluate this problem. I want to evaluate this particular problem. Now, what I will just do is that I will just say that let u equals to what? X squared minus 1. Now, what I will just do next is what? Du. It will be 2x dx, because this is a constant. Now, my dx, therefore, my dx, it will be du all over 2x. Now, I will now go back to where I'm coming from. I have integral, everything remains u raised to the power 1 over 2 with our f of indices. Now, du, okay, we have 2x here, sorry, 2x du, this is this, du all over 2x. This will surely cancel this. Now, I can now left with what? Integral of what? U to du. Now, if I should integrate this, I will be having adding 2, which is what? It will be, if I should add 2 to the upper, which is I will be having u raised to the power 3 all over 2, 3 all over 2, plus what? Plus k. Now, what is my u? My u is already given, which also implies 2u 3 all over 2 all over 3 plus what? Plus k. Now, what is my u? This is my u. I can answer that what? My x squared plus minus 1, or bracket of what? 3 all over 2. Now, sorry, I have 2 all over 3 here. Now, plus k. Now, plus my k. Now, okay, what am I doing here again and again? I can now say that I can stop here and also I think I can solve it further. I can say that what root of 2 root of x squared minus 1 or bracket of what 3 divided by 3 plus what k. That is my final answer. I can stop here. Now that is my final answer. Now let me move another problem. Okay, I want to evaluate another question like this, like this, like this. Okay, another problem like that that related to kind of something like that. Now, if I have for instance, I want to evaluate also integral of x divided by what? 4 all in roots. Okay, should I put all in root? Let me put all in root. I'll be making it interesting with the respect of x. Now, look at this particular question. I can solve it in another way. If I like, I can say that my u equals to what? 4 minus x squared or bracket of what? 1 over 2. Yes, I can say that my u squared equals to what? 4 minus what? x squared. Now, what do? I multiply both power by what? By 2. Now, if I should differentiate this, I will have 2u du equals to what? Minus 2x dx. Now, therefore, my dx, it will be equals to 2u du all over what? Minus 2x dx. This will cancel this. Now, okay, I can now come back to where I'm coming from. Now, integral, I have my x all over what? Everything becomes u. I have u. Yes, everything becomes u because my u is equals to this. Everything becomes what? U. Now, okay, on my u, which is what? Bracket of minus u all over x, because 2 cancel out here. The what? Sorry. Now, I have my du. Close the bracket. This s will cancel, this u will cancel. Left with what? Minus integral of what? Du. Now, once I want to integrate my du, it will be what? Which I will have minus u plus k. Minus 2 plus k. What is my u? My u is equals to what? My u is equals to this. It means I have 4 minus s squared or bracket of what? 1 over 2 plus k. Which also is the same thing as what? Root of 4 minus s squared plus k. That is my final answer. Now, that is my final answer. Now, you can do more on by substitute. Now, let me move on to integral of this case. In the integral of this case, that will lead us to partial fraction. Okay. Anytime you integrate, you differentiate the numerator. Now, anytime you have a function like this, prime of x, all over what? Function of, on respect of x. Anytime you do this and it satisfies, it means my answer will be equal to ln of the function of x. Now, that is my answer. Plus k, because we are still working on definite integral. Indefinite integral. Now, what that means is, for instance, if I have, okay, let me look for one simple, tan. Tan is one of them. Now, if I want to integrate tan x is tan. What is my tan? I can turn it to what? Sine x all over cos x dx. Now, tan is a very good example. If I differentiate my u, my cos x, now my cos, which is cos x, the u of this is equals to what? The u dx of this is equals to what? It will be equals to minus sine x. Minus sine x. Now, if I have this, Now, if I have this, okay, if I differentiate time, I will have yes. Now, since I have this, I can have minus here, I can have minus here. It means I have minus, I have minus. I'm still working on what? Can. Now, okay, if I have that, it means I can say that what? My function of what? My function of what? It obeys the what? Condition of what? Fx all over what? Fx in integral, which is equals to, my answer would be what? Minus ln what? Ln cos x plus k. That is my where you are to integrate now. Because of what? I've differentiated this and I have this, which is the upper case of it, which I have to. Now, let me move on to algebraic function aspect of it. Now, algebraic function aspect of it. If I have, for instance, I have a particular question like this. Okay, if I have the first one, I have integral of this case. Now, I have integral of this case. I have integral of 4x minus 4 divided by, okay, let me use 2 here. Okay, minus 4 divided by integral of 2x squared minus 2x plus 5 with respect of what? The x. Now, another one also, if I have, okay, let me first solve this one. Do you know that I can do something like this here? You have to learn how to think if you have to do integration. Integration is very, very technical. If it's very complex if you don't know how to think. Do you know I can return this to what? 2 bracket of 2x plus minus 2 or bracket of 2x squared 2x plus 5 with respect of what? X. I can do that. Yes, it's possible. Now, this my 2 can come out of this, which is I have 2x 2 all over what? 2x squared 2x plus 5 the x. Now, do you know that if I differentiate this, I will have this? Yes. If I differentiate that, I will have that. Sorry, there is problem here. There might be 2 there. Sorry. There might be 2 there. Yes. If I differentiate this, I will have that. Yes. Let me remove that 2. I think that 2 cannot help us. Let me remove that 2. If I differentiate this, I will have this. Since like differentiate this, I will have 2 and x. It means my answer will be what? 2 ln x squared minus 2x plus 5. That's my final answer. Plus k, sorry. Plus k. That's my final answer. That's my final answer. Now, I think we have done very good, fine on this part of it. Now, okay. Let me integral by parts, by partial fraction first. Integral by partial fraction. Now, integral by partial fraction. Integral by partial fraction. Now, this aspect also is one part of very wide aspect, but there are 4 or 3 conditions. There are 4 conditions that can be case. Okay, the case 1. Now, my case 1 can be x minus a divided by what? S minus b, okay, plus b, s plus c, or minus c rather. Anyhow. Now, this is case 1 of partial fraction. if I should do the partial fraction of this one, it means I want to integrate it also. Why am I doing partial fraction? It's just to integrate. The first one with respect of what? X. Now, this one, it means I can, if I should do the partial fraction of this, it means what? X minus A, bracket of X minus plus B, X minus C, which is this equivalent to, it is equivalent to, the first one, it is equivalent to A all over what? S minus plus B plus B all over what? S minus C. I can solve this partial fraction as I want. The second one, I think I will explain that when next we meet, because it's very wide, it requires one video. Now, another one is if I have case 2. Now, partial fraction must be what? Linear, which is a normal, we have 3 types of them. We have mixed fraction, we have a proper fraction, improper fraction, and mixed fraction. This one is a very good example of what? Proper fraction. Now, but if the case is now we are having improper fraction, that improper fraction, this one is just like what? Linear all over what? Linear, okay, let me use linear all over quadratic. Now, linear over quadratic. But when you are now having a case of what? Quadratic all over linear. Now, this case, it will lead us to what? Factorization of what? Of polynomial. By using long division or by using synthetic method. Any one you want to use. Now, this one will lead us to what? Long division. You factorize what? Polynomial, which you will be having with factor. This is divisor. This is dividend. Dividend. Now, this is a quotient. Okay, let me put D. I can't remember D. Now, this is what? Remainder. Now, whatever you have is your remainder. But synthetic is more better. I will teach you when we get there. Now, synthetic, how to use synthetic method. Now, another one is, in the case of, this case, you have, which is case 2, case 1, case 3. Then my case 3, if I have my XA all over what? It means there is gap. S minus N all squared, bracket of X plus M. Now, if I have this case, there is gap here. Now, this is a what? A linear. This is a what? This is a, I think, quadratic polynomial. Polynomial of 3. Now, if I want to solve this particular aspect, it means I will go like this. What do I do there? I have A all over what? S minus N plus B all over S minus N squared plus what? C all over what? S plus N. Now, can you see that how this one ascend? The first one, the second one. If it is power of 3, that's how we do. It means there will be square. There will be normal, there will be square, and there will be power of 3, and so on and so forth. And the last case is case 4. Now, when you are having, that my case 4, I have something of this nature. Ax plus, minus p divided by x squared minus b and of x. This is another case. If I should, these are equivalent, sorry. These are equivalent. Now, if I should have this particular aspect, it means I'll be having ax plus b divided by what? X squared plus small b plus, this one will now be what? C of what? C all over x. C all over x. Now, do you know the reason why is that this one, this is a quadratic, Now this one become linear quadratic. There will be a gap, one gap in between them. Now this one become a what? Linear quadratic and what? Normal variable, normal and what? A linear. Now these are three cases of what? Polynomial. I won't go deep on this thing. Why am I doing partial fraction? Is just to be able to what? To integrate. Now our next video will work more extensively on what? It will be a video for us. One video on what? Partial fraction. Integral of partial fraction. Now let me quickly to run to what? Integral by what? By part. I won't go more deep on that. I won't go deep on that integral by part because that aspect is also a very, very wide aspect of integration. That one will lead us to a lot of things in mathematics, which is Fourier series. I think most of Fourier series problem is by integral by part. Most of our Fourier series, mostly Fourier series by part. I will just introduce this video. Our next video, I'll be working extensively. It will be one video on that by part also. Now, if I have what? By part. Now, I have u dv, which is, if I should integrate this, differentiate this, I will have u v minus what? U dv. Now, if I should integrate this, that's what I will have. Now, if I should integral of u dv, it will be uv minus integral of what? U dv. Now, v. This is v now. Du. V du. Okay. Okay, v du. What am I doing? Yes. V du. Now, if I have this is the integral by what? By part. It's always in this case. For instance, you can have integral of what? X in what? X. With respect of x. This is very good. How do I choose my x? How do I choose my what? How do I choose my u? And how do I choose my v? The v. This is where problems comes from. Now, you have to understand the word init is very, very important. I won't solve any question on this part, but next video, you have to understand this word called init. Let me write it there. Init. Init. Now, init. Okay, init. Init. Now, this is very important. I is for inverse trig function. L is for logarithm function. A is for algebraic function, and T is for trigonometry function or exponential. And E is for exponential function. Now, the first one is inverse function. The second one is logarithm function. The third one is algebraic function. The fourth one is, which is T, is trigonometry function. And the last one, which is E, is exponential function. That is the condition behind this. Now, once again, this is Further Solutions Academy. This is Further Solution Academy. Help us to subscribe to our YouTube channel and share to your friend. Thank you for watching. More are coming on your way.